Hello, good morning. Hello. Hello. So good morning. Today we're going to see the practical number 3 from data structures and algorithms, and that is a program to implement general tree. So today we are going to implement or construct a tree of book consists of chapters, chapters consist of sections, and sections consist of subsections. So here we are going to create this hierarchical structure where in the root there is a book name. Now that root will have children, which are chapters, and chapters will have children, that is sections. So the root is a book name, then its children are chapters, and its grandchildren are sections of the chapters. So we are going to implement this using a linked list. And here you can see as it is a C++ program, so these are default header files, IOStream and namespace std. Now this is the node structure where we have a data part that is characters of 25. So 25 characters array is there in the data part of the node. So each node will going to have a data part of 25 characters because we are going to store book names, chapter names, and section names. Now these are the 3 links. So like a book can have maximum 3 chapters under it, that is as 3 children. And similarly, a chapter can have maximum 3 sections. Okay, so we can store maximum 3 sections under each chapter. So this is the node structure for each node, where a data part is a string. It may be a book name, chapter name, or section name. And there are 3 maximum children possible. Okay. So here we can say this is a root pointer variable, global, and this is a ch, a global pointer variable. Now, this is the first function, create tree, where we are going to create a root node of the tree, and that is using create tree function. So as we are going to create a new node, so to store that address of new node, we are going to have this pointer variable of type struct node. So why the data type is struct node? Because it is going to store the address of the node having the data type struct node, right? So here we are going to allocate the memory to the new node using a new operator. After that, we are going to ask for enter the book name, which will be stored inside the new memory, that is using temp arrow name. And then initially these 3 pointers are null. Link 1, link 2, and link 3 are initially null. And then we will check if the root is null, then assign this new address, new memory to the root. So we are just assigning an address value to another address value. That is a value of a pointer variable to another pointer variable. So this is how the root is created. After that, we will see how to insert chapters. So this is the insert chapter function, what you can see on the screen. And this insert chapter function will again create new nodes, insert them under the root as a new chapter. Like step 1, allocate memory. Step 2, ask the names of the chapter, that is chapter name. And then initialize link 1, 2, and 3 initially null. And then if the root's link 1 is null, that is chapter 1 is not available, make new node as a chapter 1, root arrow link 1 equal to temp. Otherwise chapter 2 or chapter 3. So depends whether which link is null. So depending upon that, initially we will add chapter 1, then chapter 2, and chapter 3. So this is a if ladder which checks if the root's link 1 is null, then this new node will become chapter 1, as we will store the address of new node, that is temp, into root arrow link 1. So if root arrow link 1 is not null, then we will check whether roots link 2 is null. So if roots link 2 is null, then we will store this new node's address into root arrow link 2. And if roots link 2 is also not null, that means chapter 1 and chapter 2 are already there, then we will insert this new chapter as chapter 3. So here you can see in the last else part, as all the links when get filled, we will display no more chapters can be added. Now, similarly for sections. So this is the function for insert section. So here we will ask in which chapters we want to add sections. That is, enter the sections for chapter 1, 2, or 3. So we will enter here 1 for chapter 1, 2 for chapter 2, and 3 for chapter 3. So that 1, 2, or 3 value will be cached into chap, and then we will pass this value to switch. So this switch have cases 1, 2, 3. That means case 1 to insert sections under chapter 1. Similarly, case 2 is for to insert sections under chapter 3, and case 3 will be for to insert sections under chapter 3. So case 1 for chapter 1's sections, case 2 for chapter 2's sections, and case 3 is for chapter 3's sections. Now we have we know what is the address of chapter 1, root arrow link 1. So copy this into a ch, that is a pointer variable ch, and then call this insert sec function. One function call for insert sec will insert one section under a chapter. So as there are two calls, you can see here, these two calls will insert two sections under a chapter. So you can see in each case, there are two calls of insert sec functions. That means they will insert two sections under each chapter. If we vary the number of insert sec calls, that will vary the number of sections under a chapter, right? So this is how we are going to insert sections under chapter by copying the address of chapter 1, 2, or 3 from root arrow link 1, link 2, or link 3, and then we will call this insert sec function. So let us see what is the definition or what is the body of this insert sec function. So here we can see this is the insert sec function. Insert sec function. This function will be used to insert one section under a chapter at a time. So if we want to insert number of sections, we have to call it number of times. So it is just create a new memory, ask for a section name. Initially links of that node will be null, and then we will check for that chapter whether link 1 is null. So जैसे हमने we have added the chapters under root, similarly we are checking for while adding in sections under chapter. So if chapters link 1 is null, then insert this new node as section 1 of chapter. Otherwise, section 2 of chapter if the link 2 of the chapter is null. And if link 1 is not null, link 2 is not null, then check for link 3. So if link 3 is null, this new section will become the section 3, that is third child of chapter. Okay, so this is how we are checking, and if all the links are not null, that means already 3 sections are present, so we don't have more links to store the address of the new node. So just display in the else part, no more sections can be added, right? So this is how we are calling this insert sec function for chapter 1, chapter 2, or chapter 3. Here case 1 for chapter 1, we are adding two sections under chapter 1, two sections under chapter 2, and two sections under chapter 3. After this, you can see this is the main function, and in this main function we are initializing the root equal to null. Then we are creating the tree, that is new node, and then assigning it as to the root. So root, that is book name, is ready. Then insert chapter 1, chapter 2, and chapter 3 by calling this function insert chapter 3 times, and then insert section. One call will insert sections under chapter 1, then chapter 2, and chapter 3. So there are 3 calls for insert section function to insert sections under 3 chapters. And then you can see there is a display function. So we haven't seen display function. So how we will display? So see, this is the display function. It is also a very easy function, display function. See, void display, right? So in void display, you can see if the root is present, that is if the root is not null. So it is one and the same, whether you write if root or if root is not equal to null. So if root is not equal to null, or if the root is present, then display, because that root stores book name. So display book name as root arrow name, right? And then copy the first child's address, that is chapter 1, root arrow link 1, which is what? Chapter 1, and store into ch. And then if ch is not equal to null, that is chapter 1 is present, then display chapter 1's name as ch arrow name. Now, if chapters link 1 is not null, that is section 1 is present, then display chapters link 1 and then that is no child 1's data part, that is the section 1 from chapter 1. Similarly, if chapters link 2 is also not null, that means section 2 is also present. So how you will display? CH, it's a chapter node, then its child 2, that is link 2, and the data part of that child, that is arrow name. Similarly for section 3. Now this is how we have displayed chapter 1 and its sections. Now similarly, we can display chapter 2. So just copy the address of chapter 2 in ch variable, and then you can display chapter 2's name, then it's section 1 as ch arrow link 1, then ch arrow link 2 arrow name, ch arrow link 3 arrow name, depending upon if those children nodes are having some address, right? If they are not null, then display the sections. Similarly for chapter 3, just copy the address of root arrow link 3 into ch, and then display chapter 3's name and its sections. So this is all about creating that hierarchy, and this is the output. So here we are asking for book name in the create tree function, where we are creating the root. Then by insert chapter function, we are creating enter chapter 1, that is array, then chapter 2, that is stack, and chapter 3 as queue. Now you can see while entering sections of chapter, we are asking whether we want to insert for chapter 1, 2, or 3. So see here we have entered 1. So that will call case 1, right? And where we are inserting first section for array, chapter array, that is 1D array, and section 2 as 2D array. Similarly, when we enter the sections of chapter, that is 2, then case 2 will be called when it will enter the sections of chapter 2, that is sequential stack and linked stack. Now chapter 3 is queue. So while entering the sections of chapter 3, we will enter here 3, which will call case 3, and we will enter sections as section 1 and section 2, that is simple queue and circular queue. And this is the display function, which will display book name, chapter 1, chapter 2, chapter 3, and then their sections under the chapters. Okay, so their sections under the chapter, that is chapter 1 array, chapter 2 stack, and chapter 3 there is a queue, right? So it is you can see this is an hierarchical structure. So book name, chapters, and their sections. So book name is on level 0 as at the root, then on level 1 there are chapters, and on level 2 there are sections. Okay, so I hope you have enjoyed this practical to create the general tree as we have seen in the title. So this was the title which we have implemented using general tree concept. That is, book consists of chapters, chapters consist of sections on level 0, level 1, and level 2. Okay, so I hope you have enjoyed the coding. So thank you. Have a great day ahead.